Today I'll be talking about the Cortana Intelligence Suite, really introducing the components that make it up, show examples of how you can make use of it with an example around capturing data from automobiles. So telemetry data coming into the system, being recorded, being analyzed, applying machine learning to it, and then finally producing nice visualizations with it. There's my email address. This is Cortana Intelligence. This is the main link for this page that actually points you towards developer resources, videos, the training material we have. There is a edX course as well that goes over Azure Machine Learning. So there's a lot of material. Cortana Intelligence is all those additional APIs that I was talking about, face recognition, text-to-speech, etc. That's available there. That's the gallery. So there's a lot of samples from there and templates. The cognitive services are the ones that actually have all the video, speech-to-text, and other services. The bot framework, if you're looking to build your own bots. And then finally, this long one is actually a connected car demo, and I'm just going to cover a little bit of that right now. And then that's what we'll be using as the basis of our discussion as we go through the day. All right. My name is Vivek Gupta. My position is Senior Data Scientist at Microsoft. So my job at Microsoft is really about helping customers understand how they can use the Cortana Intelligence Suite in order to solve business problems. So really help them see what all the components are, how they fit together, and then actually produce a solution that's made for their industry. So we have an example, a template that's available that you can actually deploy in your own Azure space. And it's about doing connected cars. The idea is that you install a little device inside the ODB2 port of your car, and you pair it with your phone. It can then take the data from your car, your driving habits, your miles per gallon that you're getting, or liters per kilometer that you're getting, and keep track of that, your speed. And from that, it'll bring all that data into IoT Hub. So directly from your phone, it'll pass it up to IoT Hub, where it goes through multiple paths. Some of that data all goes into Stream Analytics, and Stream Analytics acts as a director for where to send that data next. So the data goes off to storage so that you can permanently store all the data from all the users who are using this application. It actually goes off into Power BI directly to give you live updates of what's going on for the users in your system. It goes directly into a SQL database where it can go for other processing. And then it also gets processed in machine learning. And so from the machine learning, we can derive some insights about the user. How good a driver are you? Are you speeding a lot of the time? Or is your fuel efficiency very low? We can also do predictions about what sort of maintenance you might need based on the mileage of your car, how much you're driving, and things like that. So this is a sample application that we have built internally and that we've made available to anyone who wants to use it. Being able to take telemetry data from an automobile, transfer that to the cloud, and then be able to return to the user a result that indicates whether or not, how much fuel they have remaining, what's their driving pattern, are they a good driver, are they a bad driver, those type of details that we see as a common application that users who develop applications will want to build. So if we go, we have this website, and as you can see, it's a whole entire sample application that you can actually deploy yourself. We actually include an iOS, Windows, and Android device phone applications as well using Xamarin. So you can actually deploy this on a phone. You can buy the same connector, and you can actually build your own website where you keep track of your car usage if you want. But more importantly, when you deploy this, we have a bunch of scripts that actually PowerShell scripts that actually enable you to deploy this entire set into your own workspace in Azure. Right? So you can have your own subscription, deploy all of this there, and then you can start taking it apart. We have a development guide that goes along with it that shows you how each of the pieces connect to each other and shows you how the development works for it. And so you can look at the queries, you can look at everything. And that's what we're going to cover today, is we're going to cover some of that data ingestion piece for this part that I'm going to talk about, is how does that data move in there? What do these queries look like? what data options do we actually have in Azure for you to be able to do this sort of storage and analytics. And then from that, we'll move into Jamie's talk, which will be more about the machine learning and other pieces. And then we'll wrap up at the end with me talking a bit more about the visualization side of it. All right? So again, this resource, very nice. It was released at Build 2016, and it's actually on GitHub as well, so you can download the code. You'll see for a lot of the things that we're doing, we actually make code samples available on GitHub, and we have full websites that allow you to understand how to deploy these type of solutions. So what does a dashboard for something like this look like? So here we have a data, so as part of this application when you deploy it, there's actually a data generator that you can run if you don't actually want to connect your car up and buy all the accessories. And so we have a data generator running right now. Jamie started it up last night, and it's generating data, and it's making it as if cars are moving through this environment. We have the number of cars that are operating in these places. What are the models of the cars? This is real-time vehicle health. So this should be updating as we go along since the generator is running. So these data points should change over time. We probably are running them on a 15-minute cycle or something like that. They may not be happening continuously for the way we're running this. You can look at the aggression of the drivers. What are the average number of aggressive drivers based on whatever category we've said? Maybe it's how fast they're speeding. You can look at vehicle recalls, fuel efficiency of the vehicles. So there's a variety of things that you can include here, and these can all become part of dashboards as well. So that's the Power BI side of this. So this is where you end up from all of the other flow that occurs. So let's go take a look then at Azure and what we have in terms of data sources or databases, right? We have SQL database that we've talked about, standard SQL database that people are familiar with, but instead running on Azure. So it runs as a managed service. You specify, how big an environment you want, and it runs as normal. Data Lake Store, as I said before, Data Lake Store really allows you to do your queries and then scale the analytics according to your needs on a per query basis, rather than specifying, with SQL Server, when you want to, you have a big load, what do? You buy a machine with lots of cores and lots of RAM, and you scale it out. Data Lake doesn't require that. Instead, you have a standard data storage, and when you run your queries, you specify how much you need for that query to execute. All right? SQL Data Warehouse is the same way. It's elastic in the sense that you can, as you do your queries, you can adjust how much compute you need. So if you have a big query that runs, adjust the compute slider, run your query, slide it back. This is really a lot more about the people doing analytics and things like that. You can also do it programmatically. So you can request these queries via REST requests or via PowerShell commands. And during that, you can also set what you want your compute size to be. So if you're running these as batch or you're running any sort of reporting or anything like that, you can do that way. The other interesting thing about data warehouses, unlike other data warehouses on other services, you can actually pause the data warehouse. Storage continues to be a charge that you have, but even at the minimal level, you actually shut off the compute at that point. So if you only have something that runs weekly or nightly in a batch, you could actually automate the process of running your query, pause your data warehouse, and the next night bring it up again and import whatever data you need additional, and then do your execution, and then pause it again, so that you're not paying for compute when you're not actually using it. So very different from your standard sort of database usage that you would expect. Then we have other things. We have like Redis cache. We have a document DB so that you can store documents and do queries across JSON documents and things like that. So there are some additional ones, but really what we're focusing on is Data Lake Store and SQL Data Warehouse as most of this conversation. All right, so let's look at the ingestion. So if we look, we have from the vehicle telemetry standpoint, we have, let's go to Stream Analytics. So Stream Analytics, Event Hub is pretty simple. There's not a lot to it. You specify how much data you want to store and how many days worth of data you want to store. It acts as a queue, stores that data for you. You specify how much volume of data you're going to have, and so you specify how many event hubs or how many units you need of storage. Beyond that, there's not much else complicated in setting up Event Hub, but really from the stream analytics standpoint, it acts as one of the inputs to it. So you can see here, we have two types of inputs into stream analytics for this particular case. You could point to a database, you can point to blob storage, you can point to Event Hub. So here we have Event Hub source. So this is that telemetry data that's coming from the car. So it's coming directly from the car, going to Event Hub, and stream analytics is continuously reading this data in and bringing it in as a data stream. There's also some reference data. Maybe we have a list of cities, or we have a car models that we map to VIN IDs, or some other sort of thing that we're looking up, reference data. We can reference that data, and if it's below a certain size, it will stay resident in memory. We don't go query it every time a new stream of data comes in. We try to keep that data local so that we can join it with the stream of data that's coming in. So that's one of the cool things you can do is you could potentially have two sources of streaming and reference data as well, and you can actually join those streams based on the timestamp that's provided. Okay? So you can actually join streaming data in this as well. All right, and then you can have outputs. So in this particular one, we have blob storage for storing off the data, the raw data. We have an event hub, so if we want to alert the users, we may actually point from the stream, do some machine learning on them and say, hey, you have a problem coming up, and then we'll output that back to the stream, to an event hub, where we can then use some other Azure services to actually do a notification to the user, letting them know that there's a problem to their application directly. And then finally, there's a SQL database, so we're writing the data SQL. You can also, from here, you could have a Power BI output and directly write the data to Power BI and write your aggregates, but this particular job does not have that in it. All right, and then what does a job look like? So let's take a look at what a set of queries looks like. So you can see we've got 3 queries here, and you do a select on the query, but then you'll see that there will be a into, and that tells you where the data is going to go. So you select from which data source you want. So it's very similar to standard queries, right? Select from, you pick your input source, and then your out here, your into, represents where you're going to put the data. So which of the outputs that you have, you're going to put the data. So this one, you can see, is just bringing all the data in and going ahead and writing it to blob storage. So as the data comes in, go write it to blob. This next one is writing it out to an event hub. And I don't know why it's cutting off a little bit here. Right? And the last one is the most interesting one. So you'll see here, we're doing a count, we're doing an average, we're looking at a variety of values. But the interesting part here is this last group by statement. So what are we doing a count of? What are we doing an average of? And what we're doing is, we're doing it based on, sorry, there we go. We're doing it based on the model, the city, and a tumbling window of 3 seconds. So for every model of car, for every city that there is, we're taking a 3-second average and count. So it's similar to group bys, right? You're grouping the groups together as you would in a SQL query, but now we're doing things like saying for 3 seconds, treat all of these as separate groups, do some sort of average, and return the results for each of those groups independently. So very similar to group by, but the distinction here is the type of window that we're using of time for the data as it's streaming through. Tumbling windows are such that you'll never see the data twice, right? So you've got a 3-second window, and then you jump 3 seconds, and you've got another 3-second window, and you jump 3 seconds, and you have another 3-second window. You could have sliding windows as well, and sliding windows, you see the same second. So if you have 3 seconds, you keep moving along, you're seeing the same data repeatedly. So if you're doing a moving average, you would use something like a sliding window. That's pretty heavy duty if you have a large volume of data. So typically you'll end up doing something like a tumbling window. The other one that we have, which is commonly used, is almost as if you're going to sample, is a hopping window. So I'd say I'm going to do a 3-second window, and then I'm going to wait 4 seconds or 5 seconds, and then I'm going to do another 3-second window. So you're sampling these 3-second windows at some interval. And window lengths can be up to 24 hours. So you can do your daily averages and things like that directly from this, right out to your dashboard or something. And if you don't need to store it, it can just go to your dashboard directly. If you need to store it, you can take the output of that. You can have that query there twice, and you can send it into your dashboard, and you can send it into your database as well. All right, so a couple different options there. The other thing this query has is, this is the one where it joins with the blob source on event source on the VIN number. So you can see that it is joining with that VIN number. And like I said before, I believe that's what they're using to figure out the model of the car. So because VIN's, the beginning of the VIN tells you what model of car it is. So this is a mechanism you can use to actually join two streams as well. The difference is when you do the streams, you have two different types of timestamps you can choose to use on data when it comes into Event Hub. You can either use the time that it came into Event Hub as the timestamp, or you can choose a timestamp that you've actually included. And so in your query, if you look at the query language for this, there's a way to specify which type of timestamp you want to use, whether it's the timestamp that's in the data and you tell it which field that is, or you want to use the Event Hub timestamp. And that allows you to do a query that joins two different streams, and then by specifying what the difference is that's allowed between the timestamps, it'll actually join those two streams together. And so you could have, a good example of this is if you were getting temperature forecasts or something like that, and maybe you're doing energy prediction, so you're getting another set of data, and you want to join those two streams of data. You'd use the timestamp and say, hey, if it's within 10 minutes of each other or an hour of each other because of the rate at which you receive these temperature data, go ahead and join it. It's OK. And so you'll actually get the join automatically based on the timestamps. So that's the type of thing that you can do with streaming analytics. Let's take a look at what a data lake query looks like. Actually, before that, why don't we do this one? So this is Data Factory for the connected car, right? So Data Factory provides you with a bunch of information. You have the ability to author and deploy new pipelines. And pipelines represent the ingestion of data, some set of activities, and then the output of the data. And you may have multiple steps, multiple activities. And the nice thing here is you can actually view what this looks like as well. So this is our pipeline for this particular case. We prepare, you bring in the raw data events from Azure Storage. You partition those events. That's an activity that occurs. And I believe this is an activity that occurs with some custom C# code that's actually deployed to HD Insight, executed, and then that cluster comes down again. It stores that results of that. Then we're going ahead and doing some activity to figure out what the fuel efficiency is of the drivers. We're looking for anomaly detection. And let's dive into the anomaly detection one a little bit. So we can see that the anomaly detection one actually has, there's some schema preparation occurring, a Hive activity, there's a copy activity, and then it's using Azure ML to actually call out and do the detection of the anomalies to determine if there's something wrong with the car. So it's actually using machine learning at that stage in order to batch score everybody and then be able to report what's happened. All right, so these pipelines provide a variety of services that way. And then finally, write those events out to blob storage again. All right, so multiple pipelines, branching. You could have many pipelines. And again, with the Azure services, a lot of it is based on the consumption of the service, not just having the service. So Data Factory works on the basis of how often you run your pipeline. That's where the charge is. And then the use of each of the services. So storage, you can imagine, is pretty low. And I believe moving data around inside Azure, there's no charge around that. And then finally, doing the activities. You bring up the Hive cluster. There's a charge for having the cluster, depending on the size of your cluster, et cetera, your parameters that you've set there. And then you bring it down again in order to minimize the time that the service is up. Okay, and Data Factory helps orchestrate all of that for you. You can also have data on-premise with Data Factory. There's a SQL Server gateway that you can put in your premise, have it running where your database is, and there's two things that can make use of that. Power BI can make use of that gateway in order to reach data that's on-premise and bring it into the online ability for your users as a dashboard. And then the second one is for Data Factory to be able to pull data on some periodic interval, bring that data in, do whatever it needs to, do the processing, and then write the data back to your data store as well. Or write it to an online data store. It doesn't matter which one you do, but it'll let you do it either way. Data Factory has a lot of connectors for being able to talk to a variety of different data sources as well. So I have a data lake store where I've previously run some jobs, and what I'll do is I'm just going to bring up one of the jobs I've previously run so you can see what a query in it looks like. And this was a job that I was trying to do, and you can see I had a lot of failures while trying to figure out what I was doing. But this was one where I was actually trying to get some data that was in JSON format, convert that data into a tabular format, and then store it inside the Azure Data Lake. So as soon as it brings that up, I'll show you the job. Two of the things that we've provided on GitHub are these translators to show you how to take your own document formats and convert them into something that you can store in Data Lake as a tabular format if you wanted to. So we have a JSON example and a CSV example. And basically those are sample readers that we've provided C# code for that allow you to query those items from Data Lake, querying out from blob storage, and then put them into Data Lake. So let's take a look at what the script looks like. And this integrates really well with Visual Studio. So when you use this from Visual Studio and you deploy your job directly from Visual Studio up here, you can include all your code. You can actually monitor your job as it's running, see how many, how much parallelization there is, whether you're really using all the compute cycles that you've requested. But you know, here's where I'm including the samples formats one, where I'm able to take and extract these fields of data from all of these files that are located in this directory within blob storage, within this container, and then using this JSON extractor to do that extraction. So that query essentially is going out to blob storage, going through every file that's there, extracting out the necessary and relevant data that I requested, and then I can now output, and see I labeled it as my records, all that input, and I can output that, and I'm saying I want to convert that to a CSV. And again, I pushed it out to blob storage. But I could just as well have output it to a Azure SQL Data Lake table as well and stored it. But in this case, I was using this for data transformation. Take JSON, convert it to CSV, all from blob storage and back to blob storage. So you can write any C# code that you want that will act on the data that you're reading from Data Lake and add it as part of your query. And as I said before, what happens is, in this particular case, I was reading these files. It wasn't reading just one file at a time and doing this conversion for me. I told it I wanted to use 20 compute units. So it spun up essentially 20 machines with multiple cores each and was processing these jobs across the cluster for me. And I didn't have to manage the cluster. All I had to tell it was how much compute I wanted to use. And as I ran a small test, I saw, hey, 10 is taking me too long, so I'll use 20 of them, and it cut my time in half. It was great, a lot of parallelization. But it's something that you can keep testing and iterating with. And again, you're paying for the compute cycles you use rather than for having a cluster up and running all the time as you would with a typical Hadoop cluster or something. So it simplifies the management of it. And with the C# code, it allows you to extend it pretty extensively. Questions on this one?
You can import .NET libraries, I see, from the
Yes. Yeah. So you can import .NET libraries. So when you do this in Visual Studio, you can actually include all your libraries in your code and your DLLs. And so what happens is the DLLs get deployed up there. And then what you've done here is you've just essentially given your path to it so that you can execute the functions within there. So pretty much anything you can do. So if you were doing something with images, for instance, and you stored the images out in blob, you could write a whole image package that went in and read the image. Maybe it looked for the average color of all the images or something like that. So you could say, you could do a selection that said, hey, get me the average color of all these images and write it to the table along with the name of the file. And that would be a valid type of query as long as you had written the function to go compute the average value of each image. Other questions? Yeah?
question on the side. How, imagine I have a terabyte of data somewhere. I want to plug or upload to Azure. So what are my possibilities?
So there are a couple ways to do it. So if you have so I recently went through this. I was moving, I think, 2 terabytes of data from a customer in blob storage. Now they had already moved it up to blob storage. So that's one way to do it, is use standard tools, move it to blob storage, do some sort of copy, and then you can import it into these various things using, we have part of Azure Data Factory, there's some simple copy services now that allow you to move data from one service to another. But moving it to Azure in the first place, there are several options. One, let it run for a few days, have a direct pipe. But there are also services that allow you to get the equivalent of a suitcase of hard drives. So if you have a large volume, and we had a customer recently do this, we basically have a container, I don't know, small box about yay big, and it is filled with SSD drives. And so they take it to their data center, they hook it up, they move all the data to that, it gets shipped to an Azure data center, and then they take the data from that and move it in. So if you have a very large volume and you want to reduce your time, FedEx is still the fastest way to move that large volume of data. Microsoft's Machine Learning Gallery, or the Cortana Intelligence Suite Gallery, really provides a variety of things at this point. We provide solution templates so that someone can deploy a full, complete end-to-end solution and take it apart, see how all the pieces go together, and really understand the flow. We provide them with a technical guide. We provide them with a playbook so they understand how to do the machine learning, how to gather the right data in order to do the machine learning. And then finally, we show them how to present that data in Power BI as well. Then we provide many examples of machine learning algorithms being applied to specific problems. And when we apply it, we provide a little bit of background about the data that's being used. We provide machine learning actual experiments that people can use and execute and copy. It includes our code, or it may use some of our own algorithms, but we show people how we adjust the parameters. What are we doing in order to understand the data?